Hello, welcome to my second video on the staircase problem. Last time we looked at the recursive solution, which turned out not to perform very well for the number of stairs that were quite large. This time I would like to look at another solution that does perform quite well, seemingly no matter the number of steps or the complexity of the step lengths that we can take at a time. But first I want to take a look at the recursive solution, talk about why it wasn't such a great solution and what we can do about it. So I'll meet you at my surface.
Okay, before we start talking about how we can make the staircase problem solution better, let's look back at the recursive solution. So I just want to look at the same case that we had last time. We were dealing with 5 steps, and then we can either take a step, a length of 1 at a time, or a leap, a length of 2 at a time. So I can start with 5 steps. If I take 1, we'll go to 4. If we'll do 2, then we can go to 3. From 4, we can go to 3 or 2. From 3 to 1. From 2, we can go 1 to 0. 1, just 0. 1, 0, 2. And this is where I'm going to point something out. We have already done 2, okay? So I'm going to replicate this right here. We can either go 1, 0, and then 0. So there you can see that this right here from 2 and this looks exactly the same. And the same thing will happen from 3. So I'll just repeat that right down there. And go 2, 1, 1, 0, 0, and then 0. Okay? So doing this again, so 3. This right here looks exactly like this right here. So let's illustrate that a little bit more. So just do a simple chart here. On the top, we'll have the number of steps, and then here we'll have outcomes, okay? So first we could just do if we have 1 step, and we can see that all over the place. We have 1 here, and that just gave us 1 outcome. Here, that just gave us 1 outcome, 1, 1, 1. So that just gives us 1 outcome. Now for 2, again, this is something that we repeated multiple times. It was here, here, and there. In each one of those, we had 2 outcomes. There were 2 ways to climb a staircase of length 2. For 3 steps, that gave us 2 examples, one right here and the one right there. And then both of those had 1, 2, 3, 1, 2, 3 outcomes. 4, we only had 1. That was 1, 2, 3, 4, 5. And then here, I want to make sort of an observation, because it's obvious now. So from this 4 right here, there's 2 options. We have 3 and 2. But we knew that 3 gave us 3 outcomes, 1, 2, 3, and 2 always gives us 2 outcomes. So I can think about the number of ways to climb a staircase of 4 steps would just be the number of ways to climb 2, and the number of ways to climb 3. That would give us 5. So without even looking at our little diagram here, I can calculate how many ways that we can climb a staircase of 5 steps. Okay, all I need to do is look how many ways there are to climb a staircase of 3 and a staircase of 4, which should be 3 plus 5 is 8. And I can continue this for 6 and 7. So 6 would just be 5 plus 8, which is 13. And then 7 would be 8 plus 13, which would be 21. Okay? And then hopefully, or well, depending on how much math exposure you have, this sequence might seem a little familiar. It's very similar to the Fibonacci sequence. So this Fibonacci sequence, the next iteration in the sequence is just the sum of the previous two iterations. And this will give us insight of how we can come up with this new and better solution. Okay? So we'll scroll down and then we'll look into that. Okay, so let's start with a chart to illustrate the way that we are going to eventually code this. Along the top, I'm going to represent the number of steps that are in our staircase, and we'll start a little different here. We're going to, instead of starting from the total number of steps that we're going to climb, we're going to start at the fewest number of steps. So the fewest number of steps would be a staircase of 0, okay? And then let's go all the way up to 6 here. So 1, 2, 3, 4, 5. And if you're not already, please get out a piece of paper and try to follow along with you. Create the same chart that I'm doing for yourself, okay? And I know I'm very bad at this, but I know I would get a lot better use out of my YouTube viewing, or at least the educational videos, if I followed along with the user. So please do so, and then later on this video, well, in just a few seconds, I'll ask you to do one on your own, and I'll just give you the answer. Okay, so on the top, we have the number of steps in a staircase, and on the side, we'll put the lengths of the steps. So in our example that we have been using, we've been using a length of 1 and a length of 2, okay? And I'm going to do a line down, 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 down. I said I was going to go to 6, didn't I? And at the bottom, we'll have our outcomes. Okay? Now I'll start this off. Now for 0, I'm using that as our kind of base case. There's only one way to climb a staircase of 0. We're already there at the top, and I'm going to put that in red to make that obvious. Okay? And then just to make clear, I'm going to put this over to the left-hand side of the column. If my staircase is of length 0, I can't take a step length of 1, and I can't take a step length of 0. So this doesn't contribute any, outcomes, but I need this base case to tell me that, if we're at 0, we've reached the top, okay? Switch back to black. So now if we're at the staircase of length 1, if I take a step length of 1, that gives me 0, okay? And then I cannot take a step length of 2, so I'll put a null symbol there. Now what I'm going to do here is I want to calculate this 0 here. I'm going to look at my staircase of length 0 column, and that gave me 1, okay? So I'll put 1 there, 0, and then I'll add those up, and that gives me 1. Let's go to 2. So 2, I could take a step length of 1, which would leave me with 1. I could take a step length of 2, which would give me 0. Again, I am going to calculate the 1 and the 0, I'm going to look at the 1 column and the 0 column, but I'm going to look at these red numbers right here, okay? So the 1 gives me 1, 0 gives me 1. So 1, 1, add those up, that gives me 2. Now I'm just going to fill in the rest of our chart here with the black numbers. So if my staircase is of length 3 and I take a step length of 1, that gives me 2. If I take a step length of 2, that gives me 1. From 4, step length of 1, 3. Step length of 2 gives me 2. 5 goes to 4, 3. 6 goes to 5, then 4. Okay? Now I'm going to fill in the red parts. But here, so what I'm going to look at is, so for this 2, I'm going to be looking at this 2. For this 1, I'm going to be looking at this 1. For this 3, whatever we calculate for 3. For this 2, whatever we calculate for 2. Okay? So for our 2, gave us a step length of 2, or 2 outcomes rather, and then 1, 1. Add those up, that gives us 3. Now we'll calculate the 4 column. So 3, I'm looking at the column of 3, and I'm looking at the red number at the bottom. That was 3, 2, looking at the column of 2 all the way at the bottom. The red number is 2. Add those up, gives us 5. For 4, I'm looking at the 4 column, so that's 5. 3, again, the 3 column 3. Add those up, that gives us 8. Hopefully that 8 is familiar now. And then for the 6, 5, so I'll look at the 5 column, that's 8. 4, look at the 4 column, that's 5. Add those up, that gives us 13. Okay? So now what I would like you to do is try to do one of these on your own. Okay? See if you can calculate on this, and I am going to give you, so scroll up, I want you to calculate for a staircase of 8 steps, and then our step options, I want to do 1, 3, or 4. Okay? So I'll set up what the chart would look like first, and I'll give you time to work on it. So start with the base case of 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we have a step length of 1, 3, or 4. Okay? And the reason I really want you to do this is the better you understand this process, the easier it will be to understand how we'll be coding this. Okay? So I'll let you calculate this, and then when magically I'll fill in the solution. But I really encourage you to try to work this out on your own. Okay? Okay. Hopefully that you have had some time to fill out the chart. Either way, I've gone ahead and filled in the chart. Feel free to pause the video or whatever and see if you got the same answer of me, of 20 of 5. Again, if you haven't already, I really encourage you to try to fill out these charts. It'll really help out when we're coding this solution. Okay? So do that, please. And then I'll meet you back in a coding environment. Okay?
Okay, we're in a coding environment. Went ahead and set up a Python file for us to work with. jump down a little bit and we'll use the last base case that we were kind of working with. So that was a staircase of length 6, and we were dealing with step lengths of 1 and 2. We'll do more interesting things later. And we'll set up a function, def, we'll climb stairs, we'll pass it our staircase length, as well as our step list. Now, how we're going to set this up is kind of mirroring exactly how we were doing on that chart. So if you remember in that chart along the top, we had our length of our staircase. And what I'm going to do is use a list, and we'll call that outcomes. We'll make that just a blank list, and we'll start off with our base case, and I'll append to it just 1. Okay, so that's going to put in the index of our outcome list at index 0, 1. Okay. Now, as we're going through this, we're not going to be using any recursion whatsoever. We're just going to be using an iterator. Okay, so for I in range, and we're going to go from 1 to n plus 1. The reason for the plus 1 is we want to make sure that we hit all of the length of our staircase. So in this base case 6, we want to go from 1 all the way up to 6. And I'll show that to you. We'll print out I. Okay. So here, let's go ahead and call our function. So climb stairs. We'll pass it our staircase length as well as our step list. And we'll save that, and then Python step back look up.py, and hold on to your butts. There we go. Okay, so 1, 2, 3, 4, 5, 6. If I would have just left it at n, it would have stopped at 5. So we needed that that plus 1. Don't need the print anymore. Now, for every single time that we're going into this for loop, we're trying to calculate the number of outcomes for that particular staircase length. So we're starting off with 1, so we want to calculate how many outcomes there are to climb that staircase of 1. So I'm going to do temp outcome, and we'll start that at 0. Okay. Now, for step length in step list. Okay, so here, just imagine that we're in our chart, and we're looking at that column, and we need to iterate through all of the step length options. Okay. Now, for each of these step length options, we need to kind of do a little test. If the current step or staircase length that we are minus our step length highlight that to make sure I spelled it right. If that is greater than or equal to 0, then what we want to do is look back in our list of outcomes and kind of try to sum up in any previous outcomes that we had. So I'll have our temp outcomes, and then I'm going to set that equal to whatever our current temp outcomes are. There we go. And then we're going to add to that any outcomes previously that we've calculated at our current thing. So I minus step length. Okay. Now here, don't worry about having any sort of out of bounds referencing of our list. because so we started this out, we appended it to 0, and we're checking that the number of the staircase minus our step length, that's always greater than or equal to 0. And as this for loop is going, at the end, when we've calculated the number of outcomes for that particular staircase length, we're going to append that back to our outcomes. So outcomes, append, and we're going to append unto that our temp outcome. I think everything. And then once everything is said and done, we want to return our outcomes indexed at our staircase length. So since we're returning that, let's go ahead and print that outcome. And we should here, after I save, why is this giving me, what's not liking? Using temp outcomes before assigning. I think that's just a warning, it should be fine. Okay, so let's go ahead and run this, and this should give us, what was that, what is that telling us? Line 17. Reference before. Ah, look at that. Temp. I don't want to pluralize that. There we go. Temp outcome. There we go. Now it should work. 13. Good. Let's set up the example I gave you to work out on your own. So that was 8, 3, then 4. Save this. If you recall, this should give us 25. Good. Set this back to 2, 1, and 2. And I think the example I used for the recursive was 35. I'll go even higher. We'll go 40. And when we ran this using the recursive way, it took forever. So I just want to show you that this, gives us almost an immediate answer. Boom. And I can go even higher. I can go 100. And let's go even crazier. Let's go 100,000. Now, with the magic of Python, this will spit out an integer, and it will give us almost an instantaneous solution, even though the solution is not very readable. Boom. So an astronomically large number that it gave us the solution to it almost instantaneously. Anyways, so that's that. Okay, thanks for joining me for this second sort of solution for the staircase problem. Much faster than the recursive solution, as you saw. The next series of videos that will be a part of this staircase problem, it doesn't make any more improvements performance-wise to the solution that we just looked at, that I kind of call in my head the backwards lookup. That's very similar to how maybe naturally pen and paper you would calculate numbers in the Fibonacci sequence. But the next one is more of a combinatorics approach. I find it very instructive for kind of learning about combinatorics, if that's something that you haven't had a lot of exposure to. And I had a kind of fun coming up with that solution. Actually, when I first heard of this problem, the staircase problem, it's the first solution that I kind of cooked up in my head to solve it. The code is a bit lengthy, and the explanation will be a bit lengthy, but I think it is a very interesting solution, so I will hope that you'll join me then. Anyways, until then, bye.